Hey everyone! Today we're going to be discussing reflections on a figure in geometry. A reflection is when you flip a figure over a line, similar to looking in a mirror. If you were to look in a mirror and hold up your right hand, your reflection would actually appear as if it were holding up your left hand. That is known as a change in orientation. If you look at triangle ABC, your vertices are actually read in a clockwise direction, whereas the prime image is read in a counterclockwise direction. This will be further discussed later on in the video. The notation for reflections is a lowercase letter r with the equation of a line in your subscript. In a previous video on rotations, I discuss how a capital letter R is used for rotations. So please be mindful when choosing whether to use a capital letter R or a lowercase letter r for your math notation. A reflection preserves distance and angle measure, therefore your pre and prime images will be congruent. Previously stated, orientation is not preserved since the way that you read your vertices in your prime image will be in the opposite direction. However, since the pre and prime images are still congruent, reflections are known as rigid motions or an isometry. So let's take a look at some examples. Here we're going to reflect a figure over the x-axis, also known as the line y equals to 0. The key for any reflection is that you want your coordinate points to be the same distance away from your line of reflection. If we look at point A, that is 4 units away from the line, so A prime will be 4 units away on the opposite side of the line. In this case, A would go from -8, 4 to A prime being -8, -4. Taking a look at B and B prime, each one will be 8 units away, and C and C prime are also 8 units away. So if we look at the pattern from our original image, the new image after reflection over the x-axis will keep your x and y coordinates the same, however changing your y coordinate to be negated, or in other terms, changing its sign. For a reflection over the y-axis, or the line x equaling to 0, it will be the exact same concept. You want to keep the distance from the pre-image and the prime image the same away from your line of reflection. For a reflection over the y-axis, your x and y coordinates stay the same, however your x coordinate negates or changes its sign. Now let's take a look at reflecting a figure over the line y equals to x. So let's take a look specifically at point C. C is 11 units down from the line, so I'm then going to go to the line and move 11 units to the right. This will move C from -4, 7 to C prime 7, -4. If you are looking at the pattern, here, your x and y coordinates actually flip. So A would go from -8, 4 to 4, -8, and B from -8, 7 to 7, -8. Similarly, if we were looking at reflecting over the line y equals to -x, our coordinates will flip, however, they will also negate. So the x and y coordinates both become negative or change their signs as well as flip. So for example, A would go from -8, 4 to -4, +8. Now let's also review graphing reflections in a point on a coordinate grid. The most common one will be a reflection through your origin, which is through 0, 0. This is actually the same type of transformation, or will yield the same result as a rotation of 180 degrees. So if we look specifically at coordinate B, B is 8 units to the left and 7 units up from our origin. So I'm going to then go 8 units to the right and 7 units down from the origin to make sure that B is going through the origin and staying in the same relative position. This will then give me that B prime is 8, negative 7. If you notice, the pattern here will keep X and Y in the same position, however, they will both negate, changing their signs. So A would go from negative 8, positive 4 to 8, negative 4, and C, negative 4, positive 7 to positive 4, negative 7. Please keep in mind, if the center point is not the origin, I do have another video based on rotations that will further elaborate what to do in changing that center point. Thank you for watching this video on reflections on a figure. Please check out my other transformation videos for further support.